Hello, this is continuation for pre-calculus. This is lesson 5.3. Don't mind my handwriting. I try to kind of give you a long intro for this because I was trying to make you actually look at this, because if you ever need a reference, maybe screenshot it. But this part here is the most important part because now we're graphing sines and cosines and tangents maybe. We did a little bit this last year. If you don't remember, we had a draw on the walls. We actually did the tangent ones where we drew it all against the walls. But here we're dealing with sine and cosine. So if you can see here, sine. The most important parts of these, it's slightly different from the book, but this is what we use for algebra 2. We have a sine of b times x minus h plus k. Each of these letters means something. And you'll see not all of these all together, maybe at the end of the lesson, at the end of the example, but you see these a lot in different forms. A is considered the altitude. It's the minimum and maximum point. So let's say y equals 3 sine of x. That means your maximum point is 3, your minimum point is -3. That's where your starting is. So I have here the absolute value. So it's A, it's positive and negative. B is considered your period. So a whole wave is 360 degrees or 2 pi or 2 radians. So here is a whole wave here is between this here and this right here is the whole period. A lot of different graphs, they fluctuate depending on what the period is. If it's just sine of x, that means the period is 1, that means it's a normal 2 pi or 360 degrees. And then x minus h, we remember this from the last lesson, shifting left or right, and then plus k, shifting up or down. Plus means up, negative means down. Here, for a sine graph, it always starts at 0. So keep in mind, sine graphs start at 0 and they have a sentence pattern. It goes 0 up, 0 down, 0 up, 0 down, 0 up, 0 down, and that's why I have here 0 up, 0 down. Cosine, same exact thing, though there's numbers in front, in between, something's adding into it, something's multiplying into it. So here, same exact thing as the sine. So the A, the B, the H, and the K, they mean exactly the same thing. But the cosine, they start at 1. So instead of starting at 0 for sine, cosine starts at 1. So it starts at A, or I put 1, but it just depends on what A is. Here, the sentence pattern is up, 0, down, 0, up, 0, down, 0, up. And that's why I have these two up here, because that's the sentence patterns for all sine and all cosine. Example 1. F of x is equal to 2 plus cosine of x. So we have the typical cosine graph, which I have here in blue. And now it says it's 2 plus that. So remember, whenever there's 2, there's a number being added into the graph. You're shifting how many units up or down. In this case, you're shifting 2 units up. So that means for every point here, you're going to shift 2 units up. So let's say this is 2. You might have to do 3. So we're shifting it, this 1 unit up. It's going to be right here. This, we're shifting it 1 unit up. Sorry, 2 units up. So 1, 2. That's your first point. You're going to shift 2 units up here. So let's say it's 4. 1, 2. Right here. From here, 2 units up. 1, 2. Here, 1, 2. Here, 1, 2. Here, 1, 2. Here, 1, 2. So here, if you see, you have a graph that looks like this, and you can keep on going, but you're shifting all the points that you made normally. So remember, starting from this line here, it's up, 0, down, 0, up, 0, down, 0. So now it says 2 plus whatever that is. That means each of those little dots that you've made, always try to start with graphing your original graph. You're moving 2 units up every time. So this was moved 2 units up, this was moved 2 units up, 2 units up, 2 units up, 2 units up, 2 units up. B, g of x is equal to the negative cosine of x. So we know cosine of x is graphed this way. So it's up, 0, down, 0, up, 0, down, 0, up. So it's starting with the sentence pattern there, but now the altitude, there's no number there, but there's a negative sign. When you have a negative sign, that means you work in the opposite direction. So here, typically we work with up, 0, down. We're going to work backwards. So it's going to be down, 0, up, 0, down, 0, up, 0, down. So now you work from each of the points And remember, you have your period, which is 4 lines. That's what I typically call it. The 4 lines for one whole period of the function here. So now you have those 2 graphs there. So remember the altitude, or actually just the shifting. So anytime you're adding, or if there's a negative sign in front, if you're adding, you're moving however units up or down. If there's a negative, you're moving the opposite direction. So now here is when they start adding a little bit more things. Here, we're going to talk about amplitude. Amplitude is, if you look back at these over here, is the minimum and maximum point. So it starts and it ends at whatever point. In this case here, our maximum point and minimum point is -3. So that means A is equal to the absolute value of 3, which is 3. That means your 2 minimum maximum values is 3 and -3. So that's why I have here, normally it's 1 and 1, it's always 1 and 1, but in this case the amplitude changed, so that means it's getting wider or longer. So now we have 3 and -3, that's our new minimum maximum points according to our altitude. But it's a negative, so that means you don't start at +3, you start at -3. So this is our normal graph. We have it just looking like that. Here, typically for cosine, it's up 0, down 0, up 0, down 0. And I'll put it in a description box below so you know which one's which. So here, it's a -3. So instead of going up 0, down 0, we're going to start with down 0. Sorry, we're not even starting at -1, we're starting at -3. So our new altitude is not at 1, like what we normally did. Now it's at -3. So here is our new starting point. So down 0, up, so at the 3 again, 0, and at each point here, you have 4 lines, 360, 4 lines, 720. I just try to do it, I tend to do it until like I can see some sort of a wave. If you just give me a line like this, I can't tell what it looks like. So here, down 0, up 0, next line here, down 0, up 0, down, and now I have a graph that looks like that. So not only is it moving in the opposite direction, now the altitude has changed, so now it's getting a little taller. It's getting a lot taller actually. So now example 3. This is where they combine amplitudes and periods. So we know our A's are our starting points here on the top and bottom. So in this case, you don't have to draw the graphs anymore. Trying to show you there. You don't have to draw the actual regular cosine graph anymore because now you're going to have different changes in periods. First, you have to focus on the amplitude. Amplitude is this number right here. So the amplitude for this first equation, example 3. So now we're on page 423. Amplitude is 4, so that means we have a 4 up here and we have a -4 down there. So that's where our starting and ending points, the minimum maximum points. But here, it's a positive, so remember, you're starting at the +4. Now here, for the second step is your period. To understand periods, it's a whole wave in between 0 and 2 pi or 0 and 360. So here we have 2 radians over b or 360 divided by 3. These are the equations you will use to solve for your periods. So here, it's 360 divided by what b is, and b is always a number that's multiplying into your x. So remember, in the beginning, if you screenshot it, it's a cosine b x minus h plus k. So b is whatever is multiplying into the x. Here, it's 360 divided by b, which is 360 divided by 3, and that gives you 120. So remember, a whole wave, I like to draw about 4 lines. So one whole wave is 4 lines here. So here, it looks like it starts and it ends at 120, and that's one whole wave, one whole period of this graph here. To figure out the rest of it, I like to label it because a lot of times you have to label it so you know what kind of wave it is. In your graphing calculator, you'll see a lot of the waves too. But just to understand how to label them, what I do is I multiply, or I divide 120 into 4 parts. So I do 1/4 of 120. I do 2/4, or that's 1/2 of 120. 3/4 of 120, and you're multiplying it 4/4 of 120. The reason why I do this, I want to see what the pattern is. I want to see from 0 to 120 I want to see what the intervals are. To find the intervals, you divide it into 4 parts. So 1/4 of 120 is, I believe, is 30. Half of 120 is 60. 3/4 of 120, so 3/4 times 120, 90, and the last one is just 120. 4/4 is just 120. So here it looks like they're moving in intervals of 30, 60, 90, 120. That means if we want to keep on going so we can see more of a wave, you add 30 more. So it's 150. You add 30 more, 180, and et cetera, et cetera. But mainly our period is from here to here, from 0 to 120. But again, I want to see 4 parts to it. I want to see where that graph is moving, because then we have to put our up 0, down 0 points on it. Now we have our amplitude. We start and end at 4 and -4. We have our period. That means it starts and it ends at 120, but we want to continue it so we can see what the graph looks like. And now we know it's in intervals of 30, 30, 60, 90. Most of these graphs have a pattern. They're 30s, of 60s, maybe 45s, maybe 180, maybe 360 if they're very large. So here, now we go ahead and graph it. So now, 4. So it's a cosine. Cosine, if you remember, it goes up 0, down 0. So up 0, down 0, up 0, down 0. And then you have a graph that looks like that. Normally a cosine graph will be a lot smaller. It'll be like this. Now it's a lot wider. Next one, and then we're done, is y is equal to the -2 times the sine of 1/2 of x. So now we have our amplitude, we have our period. This and this. We have our a's and we have our b's. A is the amplitude. That means your starting point and your ending point. So if it's -2, that means our maximum point is 2. Our minimum point is -2. Here also, it's a -2, so that means your starting point is not a +2. It's going to be at -2. So it's going to work in the opposite direction of cosine. Sorry, it's sine. Now, the next thing is to find the period. So period is 360 divided by b. b in this case is 1/2. We have a complex fraction. To get rid of the denominator, multiply the top and bottom by the reciprocal, which this gives you 720. So 360 times 2/1, I get 720. I want to find my range because remember we're working in groups of 4. So that means I multiply 1/4 by 720, 2/4 or 1/2, that's 1/2 of 720, 3/4 of 720, and I know my last point is just 4/4 of 720, which is just 720. If you do the first two, you'll notice the pattern right away. So if I do 1/4 of 720, I believe I get 180, and that's correct. What half of 720? 360. So it looks like it's working in intervals of 180. So your first one will always tell you what your intervals are, but I just like to do all of it so you can just see the whole picture. 3/4 of 720 is 540, and 4/4 is 720. So that means my intervals is 180, 360, 540, and 720. So I can keep on going. I can add 180 to each one, but I'm not going to do that for the sake of time. But I would want you to do in your graph. Now, sine. Sine graph starts at 0 up, 0 down. 0 up, 0 down. So we always start at 0. Here, our amplitude, that means we don't go up. It's a negative, so that means we work the opposite direction. So we go 0, down, 0, up, 0, down, 0, up. There should always be a dot at every line here. Again, I'm just estimating how it's done, but this is how you will graph it. We'll do the rest of the graphs tomorrow. If you have any questions, again, just go ahead and email me. Again, if you want to hold on for tomorrow's lesson so you can continue your homework, that's fine, but I do want to see very nice graphs. I want to see everything labeled. See you guys later.